Okay, so we are working on 9-4, which is working on angle, side angle, and angle, angle, side triangle congruence. So let's draw two of those triangles. Let's start with angle, side, angle. So here's our two triangles, and we have an angle and a side and another angle. So first thing you need to ask yourself is, would I have a side in between the two angles? And I definitely do have that. So I have angle, side, angle, and angle, side, angle, which definitely works. So yes, we can have angle, side, angle. Now what about angle, angle, side? We have angle. And the reason that you have this is, if you know two of the angles, you can easily figure out the third by subtracting those both from 180. The side that you have is really important. You know that AAA does not work. But if you have a side in there, then you definitely can use that to prove that the triangles are congruent. We'll see that later on. So then we also have to look at angle, angle, side, which would be angle, angle, side, and angle, angle, side. And yes, angle, angle, side would also work. There's only one size that this remaining third angle can be. And because you have that side that is the same in both triangles, it would have to be exactly the same size triangle. There's no other option for that. Okay, so does angle, side, side work? So let's try that. So let's say you've got a 30-degree angle. Let's say we've got a 30. And I make my triangle like that, right? Or I could have a 30-degree angle. One of our special triangles is a 30, 60, 90 triangle, right? So angle, side, side, because that's the one surrounding. Let's try that. Well, I can look at that right there, and I know this is a 30, 60, 90 triangle. I know that's not going to work because this is an obtuse angle right here. Okay, so angle, side, side does not work. Doesn't work in life, doesn't work in geometry. Okay, so you're just now going to look at the triangles down below and decide if they're congruent or not by ASA or AAS. Okay, so here we have angle, angle, side, angle, angle, side. So we do have AAS, and that's fine. Here you have an angle and a side. You also know that this angle is congruent. We can put two curves in there because they are vertical angles. So now you have angle, side, angle, angle, side, angle. Okay. Here we have an angle and a side and another angle. An angle, this side is the same for both triangles. So that would also be angle, side, angle. Okay. So here we've got an angle, and our angle in the middle will be congruent because it's vertical angles. Here we have angle, angle, side, angle, angle, side. So that is okay. Here we've got angle, let's see, let's start with the 3 ticks. So we have side, side, angle. So that's side, side, angle. Here we've got angle, side, angle, side. So those are not congruent. Needs to go in the same order. Here, if I know this is a 90-degree angle, then by definition that has to be 90 degrees because I know on the whole line can only be 180. So we have angle, and we have this side which is reflexive, is looking at itself in the mirror. So we have angle, side, angle, angle, side, angle. Oh, Mia's here. Hi, Mia. Just scared me. That's okay. So we have, here we have angle, side, side, angle, side, side. Uh-oh, we have ASS. ASS can't have any ASS. No, that is not congruent. Okay, and let's see. Here we've got angle, angle. This side is the same for both triangles. We have angle, angle, side, angle, angle, side. So that is congruent. And then we've got side, 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 side. So this is a throwback to 9-3, but that's a side, side, side. Okay. Actually, you also know that these would be congruent because those are parallel lines with the transversal. So you also know that you have alternate interior angles there and there. So we could also look at it as ASA. Okay, a couple ways. Sometimes there's more than one way to prove a triangle congruent. Okay, so let's do some quick little baby proofs. So given that X is congruent to I, so let's mark those, and XJ is congruent to IH, prove that JHI, so JHI is congruent to HJX. So we're proving that this triangle is congruent to this triangle. Okay, why are the two triangles congruent? So let's see what we have here. So we have, let's see what we know about that. They are congruent. What do you know about this side here? We know that those are congruent because they're the same line. We also know that we have two, if these are parallel lines, and these two angles would be equal, which means that these angles are also equal. So we have an angle and a side, an angle and a side. So let's write that out and say that they are congruent by angle, side. So HJ, all the things that we marked in, those are our given reasons. Okay. Then I know that JH is congruent to HJ, and that's the reflexive property. It's looking at itself, right? Then I know that angle, and you have to be careful how you mark this, HJI, angle HJI is congruent to JHX by alternate interior angles. And then I know that what I'm trying to prove, triangle JHI is congruent to HJX by angle, side. I have an angle, and a side, an angle, and a side. Oops, sorry. Angle, side, angle, side. Okay. Last one. So given that AC is equal to BC, so AC is equal to BC, and that CP is perpendicular to AB, so this line comes down in a perfect T, prove that ACP, this triangle here, is congruent to BCP. Okay, so let's write in the things that we know. Those are given. If something is perpendicular, it means that it creates what kind of angle? Well, it creates a 90-degree angle. So I know both of those angles now. Okay. Let's see, what else do we know? So we also now if you take that middle line out, we have an isosceles triangle. We learned about that in the last section, that if you have an isosceles triangle, two sides are equal, and the angles directly across from those sides are also congruent. So angle A is going to be equal to angle B. Okay, so we can put a few things in here now. Let's talk about our this angle right here. So angle APC, is congruent to BPC because that's the definition of perpendicular lines, is that it creates a 90-degree angle. Okay. Then we know that angle A and angle B are congruent because that is the definition of an isosceles triangle. So let's see what we have now. Well, now we've got an angle, or if I go this direction, I have an angle, side, angle, side. So right there, I'm good. I have enough to prove. If I wanted to keep going, I know that CP has to be equal to itself because it's the same line, right? And that's reflexive property. So I have a few ways I could prove this triangle, these triangles congruent. I have, let's see, angle, side this way. I have angle, side this way. Okay, so Let's just use what they're asking us. So triangle, and I don't even need 6 steps to do it. So triangle ACP is congruent to triangle BCP by angle, angle, side, angle, angle, side, or angle, angle, side, angle, angle, side. Either way. And it only took us 5 steps to get there instead of 6. Okay, so this should be common sense, should make sense. So if an triangle is equilateral, then all sides are equal, right? And if a triangle is equiangular, then all angles are equal. But by definition, one can't happen without the other. So if our sides are equal, then it means our angles must be congruent to one another also. Oops. And by the same token, then if our angles are equal, then our sides must be equal or congruent. And that's it. That was 9-4. Quick, easy, to the point. Thanks.